Moving on to 7.4, I like to call this section the why does your calculator do what it does section, because we're really going to be exploring, why when your calculator, why when you plug in something does it give you this answer versus another answer, which I was going to go into a big long thing, but it will make more sense when we're done. So here we go. Inverses of trigonometric functions. This is the graph of sine, cosine, and tan. First question is, are they functions? How do you know? You draw the vertical line test. Do they all pass? Vertical line test, that means that for every x value, you only pass one y value. And yes, every single graph passes. So yes, they are functions. Well, let's do a little recap way back to chapter 5. What is an inverse? An inverse graph is obtained when you reverse the x and the y values. The inverses of sine, cosine, and tan are shown below. So you'll notice that the x-axis becomes the y-axis and the y-axis becomes the x-axis. So your angles are now on your y-axis and your y values are now on your x-axis, right? So it goes from -1 to 1, and then you can see the period is 2 pi. Now, what we want to know is, are these inverse graphs functions? Well, no. So what's that going to mean to us? Well, we're going to learn a new term here, which is one-to-one functions. Actually, I think we did this in chapter 5. Remember, we determined if something was one-to-one if it's simplified to x. Anyway, if something is one-to-one, then the original and the inverse graphs are both functions. To be one-to-one, the original graph needs to pass the vertical and horizontal line test. So what we're pretending here is, if I only gave you these graphs and said, are these graphs one-to-one? Well, you know that they're functions. But to determine if their inverses are functions, you could draw horizontal lines. And if they pass the horizontal line test, then their inverse is a function as well. Now, we can also determine that by looking here and saying, well, I drew the inverses and they failed the vertical line test. So, are the graphs of sine, cosine, and tangent one-to-one? No. The inverse graphs are not functions. Now, why do we care about this? We care about this from a calculator standpoint. When I plug the sine of pi by 2 into my calculator, it can only give me one answer, 1, because this is a functional relationship. If I look at this graph, and instead of plugging in pi by 2, I have to plug in something like y is a half, there's an answer here, there's an answer here, there's an answer here, and there's an answer here. So because these inverse functions or inverse graphs are not functions, our calculator would blow their brains if we didn't make them functions, right? They would explode because they'd be like, how many answers do I give you? There's infinite numbers of answers. So what we do is we now restrict the range of the inverse functions so that we have a function, or so the inverse graph, so that we have a function. So here we go. What we do is we take a portion of the inverse graph so that we can define it as a function. So that when you plug into your calculator inverse sine or arc sine, we can put in something like a half and only get one answer, and everybody just gives a sigh of relief. Now, the question is, what answer does our calculator give us? We did explore this in chapter 6 a bit, but this is like the concrete place that we explore it. So if I was to look at the domain of an inverse sine function, you're allowed to put in x values from -1 to 1. But your calculator will give you output values between -pi by 2 and pi by 2. In other words, your calculator can only give you answers in quadrant 1 and quadrant 4 read in a negative direction. I find it really useful to look at that restriction instead of like this. I'm never going to memorize this, but I look here. what they're doing is they're giving me answers between pi by 2 and negative pi by 2, or negative pi by 2 and pi. So they will always give me the positive answers in quadrant 1 and the negative answers in quadrant 2. Let's look at the cosine graph. Now the cosine graph is a little bit different. We can't restrict it the same way between here and here because then everything's positive. So what they do is they go between 0 and pi. So for this one, again, my domain, so the x values that I can put into my calculator are anything between -1 and 1, but my calculator only has the ability to give me answers between 0 and pi. So what does that look like? Well, for cosine, it's here, between 0 and pi. It gives me positive answers in quadrant 1 and negative answers in quadrant 2. Remember, C-A-S-T. So really it had choices between quadrant 1 and quadrant 4 for the positive answers, and we were like, well, quadrant 1's the easiest. And then it had a choice between quadrant 2 and quadrant 3 for the negative answers, and quadrant 2 is the smallest. So they give it to you in quadrant 2. So let's look at tan. Tan, what they do is they restrict it the same as they restrict the sine function. So it's also between negative pi by 2 and pi by 2, because we get all of our positive answers in quadrant 1 and we get all of our negative answers in quadrant 2. Negative. So pi by 2 to negative pi by 2. Now I left the domain bit for a bit because what are you allowed to put in for tan? Well, you're allowed to put anything from negative infinity to infinity. Tan doesn't have the same restriction as sine and cosine. So for sine and cosine, you can only put in x values between -1 and 1. Tan, you can put in whatever you want. And then the outputs for sine and tan will be between negative pi by 2 and pi by 2. And for cosine will be between 0 and pi. All right, let's look at what that means to us. Well, we're going to find each of the following exactly in radians. You're going to watch your range restrictions, and then you're going to check your answers with a calculator and put it in degrees just to help it make sense to you so that you know that we can do it either way. So for example, if I take the inverse sine of a half, really C-A-S-T, I could have an answer in quadrant 1 or quadrant 2. Because of my restricted range, I had to think about that, it's always backwards for me, right? Because of my restricted range, it's going to give me the answer in quadrant 1. So if I put in the opposite is 1 and the hypotenuse is 2, this is my pi by 6 special angle. So for this one, it would be pi by 6. If we look at the inverse sine of negative a half, again, if we were doing these previously, you would have told me that the answer could be in quadrant 3 or quadrant 4. Because it's thinking about what our calculator does, we know the answer has to be in quadrant 4. So then we draw it in. The opposite is 1, the hypotenuse is 2, the opposite is the negative, and it's my 1, 2, root 3, and then my angle would be pi by 6, but read in a negative direction because it's between negative pi by 2 and pi by 2, so it's going to be negative pi by 6. Okay, so let's just double check those with a calculator. So what you're going to do is you're going to put your calculator in degrees, and you're going to type in inverse sine of a half. So inverse sine of, I'm just putting 0.5 because I'm lazy. Look, I get 30. If we do the same thing again and we go inverse sine of negative a half, I get negative 30. We're winning. All right, let's move on to cosine. When we look at cosine of a half, we know from CAST that we could have a positive answer in quadrant 1 or quadrant 4. Because this is thinking about what your calculator does, it's thinking about hitting inverse cosine, we know that we are going to be in quadrant 1 because you're restricted to quadrant 1 or 2. So now if we put in that the adjacent is 1 and the hypotenuse is 2, it's my 1, 2, root 3 triangle, which makes this angle pi by 3. So this would be pi by 3. And if I did it of the negative, oh, I wrote TT here, ST. If I did it of the negative, it's the opposite. It could be in quadrant 2 or it could be in quadrant 3. But we know because of my restricted range that it's going to give me the answer in quadrant 2. So if we put in that the adjacent is 1 and the hypotenuse is 2, it's a negative 1. It's my 1, 2, root 3 triangle, which makes this pi by 3. Now, because we're giving it in quadrant 2, this is going to be 3 pi by 3 minus pi by 3, right? So pi minus pi by 3, which is 2 pi by 3. Now let's check those with my calculator. So if I go inverse cos of 0.5, I get 60. Awesome. And if I do inverse cos of negative 0.5, I get 120. I'm winning. All right, let's do tan. Tan, same thing, right? Where could tan be? Well, C-A-S-T. It could be quadrant 1 or quadrant 4 or 3, sorry. But we know that because of the restricted range, we're choosing this one. Right? We don't even need to draw this one. And so for it to be a 1, it's going to be my 1, 1 root 2, which makes this pi by 4. If we're looking at negative 1, maybe you guys are already getting the rhythm, right? I don't have to put where it could be. We know that it has to be between negative pi by 2 and pi by 2. So I am going to choose down here, which makes this my negative 1, 1 root 2, which is going to give this as negative pi by 4. And that's the weirdest part, is that it doesn't give you, 7 pi by 4 as an answer. Your calculator wants to give you the smallest possible answer, so it just reads it in a clockwise direction. And again, if we were checking this, we'd go inverse tan of 1, and we get 45 degrees. And we go inverse tan of negative 1, I get negative 45 degrees. Awesome. Second thing that we're going to do here is just what if they were reciprocal functions. So if you had something like the cosecant negative 1 or the inverse cosecant of x, then if you remember back to chapter 6, we could write this as the inverse sine of 1 over x. If you're not okay with that, go back a step. If this had been, sorry, I'm writing that wrong. If this had been the cosecant of some angle equal to x, and we wanted to know what the sine would be. This is x over 1, so it would be hypotenuse over opposite. So the sine of that angle would be 1 over x, and then you're just taking the inverse function of it. So if you have this inverse secant, or the arc secant of x, it would be equal to the cos of 1 over x. If you had the inverse cotan of x, it would be the tan, or inverse tan, of 1 over x. So now if I ask you questions like these ones, now if you're comfortable with secant and cosecant, you don't actually have to change them to sine and cosine. Most people are just so comfortable with sine and cosine, they don't like this. So you could change this to the cos of a half, sorry, inverse cos of a half. And then cosine is restricted to quadrant 1 or 4, and because it's, 1 and 2, and because it's positive, we're going to be in quadrant 1. So it's my 1, 2, root 3 triangle, which makes this pi by 3. And again, if you're comfortable with secant, this would just be hypotenuse over adjacent, and then you could still get the same answer the same way. All right, maybe pause the video and give this guy a go. This would be the inverse sine of 1 over 0, which isn't going to work at all. I had to think about that one for a second. I'm like, sine is never undefined. I think I was making up questions when I was doing these. Let's just change this to a 1. It should be a 1 in your notes. Okay, so we're going to do the inverse cosecant of 1. And then that's going to be the inverse sine of 1 over 1, which is still 1. So if we take the inverse sine of 1, again, we want to think about what quadrant we're going to be in. Now, sine follows what? Y or x? Right? Because if it follows x, it would be here. If it follows y, it's here. It's here. Okay? So this one would give you pi by 2 as an answer. Awesome. The last thing we're going to do is finally just officially touch our calculator. All right, so like I was saying, now we get to just use the calculator and let it do its job. And what we're going to do is find these in radians and degrees, just to sort of get you used to seeing radians as a decimal and then relating that to a degree. So let's start with our calculator in degrees and do all 3, and then we'll put our calculator in radians and do all 3. So we'll start with the inverse tan of negative 1.265. So I'm just going to go inverse tan of negative 1.265, and I get, now this is my calculator in degrees, So I'm going to get 51.7 rounded to the nearest tenth of a degree. Now for these ones, you just have to remember that rule for reciprocal. Your calculator does not have an inverse cotan button. So you're going to be inputting the inverse tan of 1 over 1.265, which is going to give us what? Inverse tan of 1 divided by 1.265, which gives us 38.3 degrees. Sorry, I had a moment of panic attack here. I forgot my negative sign. I was like, why is this not working? So when you do the inverse tan of a negative, remember you are expecting your answer in quadrant 4. And when we did the inverse tan of a positive, we are expecting our answer in quadrant 1. It's always good to check. Little mistakes like that can happen where you type something in and you just, you're looking at your calculator, but you don't even see the negative, so just make sure you know it's there. And then this one, we're going to play plugging in the inverse cos of negative 1 divided by 1.1677. It doesn't matter where you put that negative. Now let's think ahead of time where we're expecting that answer to be. So we're going to be expecting it to be in quadrant 2. So inverse cos of 1 divided by negative 1.1677, which gives me 148.9 degrees, which is definitely in quadrant 2. Now let's just practice again. And again, not that you need the skill with your calculator, but let's just make sure you guys know how to put your calculator in radians. Even I had to figure out my button's set up, and then I have to choose radians. If you have a TI-83, you're going through math. Some buttons have a DRG, or some calculators have a DRG, and you just have to hit that and it switches, so whatever one it is. And then let's plug them all in again. So inverse tan of negative 1.265 is going to give us, now this is in radians, negative 0.9019 radians. So weird. Right? But it's less than half of pi, which makes it in quadrant 4, right? Same thing for this guy. Let's plug in inverse tan of bracket 1 divided by 1.265, which is going to give us positive 0.6689, again in radians. And then lastly, this one, inverse cos of 1 divided by negative 1.1677. which gives me 2.5990, which is almost, you think of quadrant or pi being 3.41, and then you've got pi by 2 being half of that, which would be what, 1.705, or whatever it is. Okay, so that it's going to fall in quadrant 2. So again, using your calculator, just recognizing that answers in degrees look weird, or radians look weird, and answers in degrees, you can kind of visualize what quadrant they are in.